In this project, I will demonstrate how to make a 3D mesh plot. This is Java Project Mesh Plot. Here is a list of the classes. The most important classes have been starred. This class provides a dynamic mesh plot for the exponential function. The mesh functions are stored in this class here. Exponential and Ackley are the two functions that are being demonstrated. The frame class provides 4 buttons: static, dynamic, clear and stop. The mesh object holds 2D arrays. We have normalized device coordinates, and this class provides a static mesh plot for the Ackley function. This particular class is used to stop the thread for the dynamic plot. Here we have the Ackley function. This is the x-axis, the y-axis and the z-axis. Static, dynamic, clear and stop are 4 buttons. This code fragment is for to set up the Ackley function. And this block of code here generates the values between -4 and +4 for the x and y values, which are fed into the Ackley function as double values, come back as a double value, z, and then it's cast to a float, and here we have a reference to the mesh, and we put the z value in here, and this block of code is just test code, which is switched off. The number of steps is 41 for the exponential function and 101 for the Ackley because it has more resolution. So the values for the Ackley -4 to +4. This is the exponential plot, a test plot, and here we've got the e to the -x over tau squared, and then we're adding them together to get a 2D surface. This is switched off by default, but it changes the shape of the plot, that particular block of code. And again we've got the z value coming back, and we're putting it into the mesh reference. This is double, but this code here is double again, right? So then we're casting it here with a float. So mesh is a 2D array. We have various variables to define the resolution. In this case, the range steps are 41 for expo, and Ackley 101. The function, the z, is a function of x and y, which is a 2-dimensional arrangement. Scan across the 2D array and insert the z values. That's what's happening here. Expo, we're going from -1 to +1, -4 to +4 for the Ackley. So calculate and insert the z values into the 2D array. All axes are normalized to the range 0 to 1. I've loaded the project Mesh Netbeans 21 into Netbeans. I'll do a clean compile and run it. This is the Ackley function. That represents 0, and this represents somewhere around 0.8, so it fits into the box. I can clear that and plot a dynamic plot. This is the exponential function, dynamic plot. This is running within a thread, and I can interrupt the thread by pressing stop. And clear the screen by pressing that. This is the static mesh plot, and currently it's set. There's a switch here so that it runs Ackley. I'm going to switch it across to run the exponential function and change the resolution of the exponential function to 21 and then run it. Okay, so I'll clear that. The next thing I'm going to do is to switch on the rods and the dots. Switch off the mesh. You'll see what this is all about in a moment if I run it again. The dots are the green dots here, and the red lines, I'm calling those rods, and the rods represent the Z height, and the dots are the position. You know, for example, in this example, I think they've got 21 on each axis. These are the measured X and Y positions. So I can clear that. Stop. And if I want to go back to just plot the mesh and remove the rods, and I'm calling rods, you have to do this business here, and then I should be able to run it. Now you can see the green dots, and these are all the X and Y, the X and the Y values that have been passed across, and the height is the Z. I can clear that. I hope you found this demonstration interesting.